Current not only is helping me, is against me. It's going to generate a flux opposite of to what I have. What is going to happen? The flux is going to get smaller. So what happened? Voltage is going to get smaller. Still, you are going to have a little bit current here, very small. Again, this little current is going to reduce the flux. It's going to be a positive loop here. The voltage is going to go to zero. Basically, they say you demagnetize your machine. This one is magnetized, right? If you demagnetize a shunt machine, you do this one wrong way. You do this one wrong way. So, can you start the machine? What did you do? Basically, what did you do? You brought this one to zero. You didn't do a very bad thing, you know, but now I close this switch and I'm looking, why the voltage is not going up, and keep thinking. Let's show it up. 2 minutes, 3 minutes, right? I'm going to go switch down. Do you think I'm going to go up? No. What happened? I killed my residual flux, right? There is nothing there anymore. Bring me up. Right? I wrote this one to zero. If this is zero, think about it. If this one is zero, if I rotate this one, how much voltage am I going to see here? Zero. So can I have, will I have any current in here? No. So when I was a student, you know, or professor said, okay, what you are going to do, you have this one here, and you have voltmeter here. He said, okay, so you are standing there, close this switch, look at this voltage. So before closing this switch, there's some voltage here, 5 volts, something like that, right? He said, close this one. If this voltage went up, oh, you're good, there you go. If this voltage starts to go down, open it. You were wrong. You put it wrong direction for the winding, right? Go change the direction. Now, so nobody told you this one. Now you kill the P residual. What should we do? Should we throw out the motor, or there is a way to fix it? How? How? No, we have to magnetize it because we magnetize it. But how? Huh?
You apply voltage.
Just run it as a separately excited machine, right? Yeah. We can generate some flux with the source here, right? We can magnetize it a little bit again, but next time be careful, don't do the same thing, right? And just you run it as a separated excited machine. You magnetize the core again. This one is going to come back. They stay there, and you look at it. So there is a 2 directions go for this one. I think, hopefully you will try this one in the lab. You know, you can see if you go wrong way, the voltage is going to go down. If you go right way, the voltage is going to go up. That's the right connection. So we talked about this one. Let's put it on the curve. Let's put it in this curve. See how it's going to work out. Let me see what it does here. EA versus IF. EA versus IF. This is this no load curve, right? And I have another one here. So this voltage, this breaker is open right now. There is no IF. So if this breaker is open, this is a VT, right? We know, let me break this one. We know VT, this is the generator, is equal to EA minus RA IA, right? And 2 VB, I never did 2 VB there. There is no load. This one is open, right? So we have a little bit drop here. And usually this current is very, very small. You got no load, right? There is no load here. No load usually means very, very low current, right? It's not exactly like that, but we say RAIA is very, very, very smaller than EA. So basically, VT is almost equal to EA, almost, right? There's a little bit rough here, but I will draw how the system is going to start to work. Another thing, VT is equal to what? Somebody tell me. Which in this case is IA, right? This one is open here, right? This is the IA and this is the IF, right? is another line here. I'm going to draw this one. What is this one? This is the EA. How did I get this one? Because of this equation. Right? Now, let's start. We are getting to the class. I am here. This is the E0. Right? This much E0. How much current I'm going to generate? How much current I'm going to generate? I'm going to generate this much current, right? Right? If this voltage is almost equal to here, forget this one, right? It's going to be E0 divided by RF, right? So basically it's going to be this value, right? This much IF0. How much voltage I'm going to generate? I'm going to generate this much, right? If I have, see, this is the no load curve, EA versus IF, right? Just remember. If I have this much current, how much voltage I'm going to have? Right? That's the voltage I'm going to have, right? Or if I have this much voltage, it's going to be equal to this much current, right? Now let's again start here. We have a little bit voltage because there was a little bit feed residual, right? So this and this voltage is almost equal to this voltage, right? So this voltage is going to generate. Why did I come to this line? Because see here, this is this one, right? If I have EA, I want to find out how much is IF. Is going to be divided by RF, which is this line, right? Now I have this much EA. How much current I have? Should I go here? I can take this one? No. It has to be on this line, right? This is the next step, right? So I have this much IF. How much voltage? This much, right? Again, this one is going to give me this much current, this much voltage, this much current, this much voltage, this much current, this much voltage, this current, this voltage. You're going to end up with that. And slowly you are going to go there. If you are going to put an arrow here, put it like this. This is the way you are going. It's really interesting, right? See how a simple machine, how it does work. Yeah. If you go wrong way, they're going to go this way. They're going to move here to go here. That's what you do wrong. People is wrong with it. I think we have to stop. I'm just getting excited and I just make the fresh.
Is it end up being a lot smoother because the inductance?
Yeah. This one is real life. I just have to I'm not very good with wrong.
You could be somewhere between the two.
It's based on the hobby with the machine. But it can go very fast. How much is the L is the liquid air share? This is the liquid air. If it's a small L, it's going to go very fast. If it's a big L, it's going to go slowly and very fast. I'll show some examples, this one. On Sunday, I'm going to wrap up the DC machine hopefully. And hopefully we can start the production machine. Okay, so I don't have
I had like 5 people stuck right